É uma grande honra receber Patrick Miller. Ele vai estar discutindo segurança no mundo industrial. É um grande tópico e é com você, Patrick.
Thanks, Raphael. So today we're going to be talking about security in the industrial world. The industrial world it's not the same thing as your standard Windows and Unix environment. It does have some of those components, but it's mostly these purpose-built machines that kind of run our daily lives. Talking primarily about cybersecurity in this space. So you always have to set the tone at the beginning of a discussion like this, and probably throughout the event you've heard about what the adversaries can do. I like to simplify it down. They basically have three things you don't. They have people, they have money, and they have time. And I don't know any organization out there that has all three of those things. So you're going to have maybe one of them in some cases. If you've got two, you're probably pretty lucky. So the main thing is you're outgunned. I mean, that's really, in no uncertain terms, your adversaries likely have more resources than you do. I think that's probably the biggest challenge of all. Now, do they need to be particularly sophisticated? Do they need to do like nation state level or kind of non-government organization level, I guess, funding and resources to damage you? No. In a lot of cases, believe it or not, it can be something as simple as a standard, Excel macro or a phishing link. So it doesn't necessarily take a kind of an enormous amount of sophistication, but even though it doesn't, they have that if they need it. And I think probably the most, I guess, underappreciated part of that is the timing component. There are some organizations or adversaries that will wait a very long time to achieve a specific goal and expend an enormous amount of resources to do so. So, don't think for 1 minute that, you probably could face off against any of the well-resourced adversaries. If you are a target, you will likely get penetrated in one way or another. And at that point, it comes down to resilience and operating kind of through something versus preventing it. One of the other, I guess, threats, so to speak, to the industrial world is innovation. There's a lot of security professionals at this time, really, that are, saying, slow down, put on the brakes. We need to stop the IoT and IIoT before it gets too much. We need to get security built into these things. I don't think that is a realistic expectation, unfortunately. I mean, don't get me wrong, I would love it if we could actually get security built into these things in advance. I don't think there is a high likelihood that's going to happen. Humans are driven to innovate. You cannot stop it from happening. So trying to slow it down, you're going to expend a lot of your own energy, and you're probably not going to get a lot of success out of that. So I'm trying to coach a lot of the professionals into redirecting that energy into, instead of trying to defeat it, make friends with it and teach it good manners. It's probably a best approach. The unfortunate reality is for a lot of the professionals in our space is our job is cleanup. We are, the custodians of the janitorial service for, people's mistakes and errors and behaviors and practices. So that's part of the job, unfortunately. Innovation is not going to stop. It's not going to slow down. If anything, it's only going to get faster. We do it as humans. We're going to use machines to do it for us and with us through AI and ML, artificial intelligence and machine learning as well. So innovation is only going to go faster, and it's going to disrupt more things on a more frequent basis and on a wider spectrum. So instead of trying to fight it, get on board and begin innovating yourself and thinking of new and creative ways to solve this problem that don't require you to stop everything before human beings can move forward with their kind of general nature, frankly. The other part of this kind of the innovation thread is there's a lot of talk about IT, information technology, and OT, operations technology, which is the industrial control systems space, the OT side of things. Today, you really can't buy a piece of operational technology that doesn't look like IT. It's looking more and more like IT every day. They're all digital components. There are no more analog components. They're now coming with more and more of these services, every single possible type of connection, whether it's infrared, Bluetooth, Wi-Fi, you name it. It's going to have everything in it. Do you need all of that? Well, that's up for debate. In a lot of cases, in the industrial side, we say we don't need those things, but the vendors are making them and we're buying them. And at the end of the day, here in not too distant future, it will all just be technology. It's not going to be anything different between IT or OT. It's really how you use it and the different types of protections you apply to it. So, at some point we need to stop the bar fight, frankly, between IT and OT, and just realize that it's all technology, and we really need to lean on each other for how we're going to manage these things going forward. Another key part about our future in the industrial space is we have always thought of ourselves as kind of the operations side, the product side. We're pushing electrons, we're pushing water, we're refining things, we're creating product. That industrial component has always been the most important part of the business, right? You can lose like customer billing, for example, and you can estimate a bill, but you still need to keep the water and the power and the gas flowing. So the operations side has a different perspective about kind of reliability and uptime and availability, resilience, and the process must always continue, never go down. That is very different from the enterprise side, where it's someone loses a little bit of money, in some cases a lot of money if there are disruptions, but no one dies. No one, really gets injured, or there's massive destruction to the facility, for example, or, enormous amounts of lost product that just cannot be recovered. That can be quite catastrophic. So the difference is in the future, or even today, we are using all of these new innovative digital systems that we are running our operations with, our operations technology, now that it's all basically digital and it creates data streams. All those data streams basically are money feeds. I mean, data is money. Data is the new oil. Some call it the new toxic waste. Either way, you make an enormous amount of money off of data. So there is likely a time here very soon where you are making as much or more off of the data about your product than the product itself. I know that sounds strange, but your business is transforming in a way where data is becoming a much larger component of the financial stream, the revenue stream for the organization. So the connections to the OT side, the connections into the industrial control systems, that data will be needed to make business decisions in tighter cycles, for more efficiency and tighter management of the overall business kind of bottom line, the dollars. So you are not going to be able to fight the movement toward more of the IT style systems and more data connections for what's going on in the industrial side, because it is now all merged together, and it's all how the organization makes all of its money, and not just the money off of the product that you create, or the energy that you move, or the water that you move, for example. So in reality, it's not just what the industrial component is, that's your business. The data about that is now just as important for the business as the product itself. And I'm not sure that everyone realizes that they're effectively now a bank. I mean, if data is money and you have an enormous amount of data that's worth money, you are just like a bank. So you need to shift your thinking in terms of how these systems are not just protected on the industrial side from sabotage or engineering level events, but also from the data protection components. So there are some differences in how you protect these systems, how you protect the OT side versus the IT side. And I'm going to go through some of these things that we've seen. These are proven to work in the industrial control system space. This is not just, Patrick thinks these are great things. I've actually seen these work. There are multiple papers produced on this. And what you're seeing is kind of a merge of what I've seen out of DHS and CCI and a bunch of other really good organizations that produce, actual what works in the field kind of thing. A lot of this is based on, we don't share a lot of risk data in our space. We don't share a lot of security event data. So this is based on what we're getting from the professional side, as well as those incident responders that have had to actually come in and fix things. Probably the key thing first is identify what you have. I know that sounds kind of mundane or pedestrian or, simple. It's not. It's probably one of the most difficult things you could do, especially in the industrial space where you've got a lot of small endpoints that are purpose-built, and they're now creating a data stream. Those need to be protected the same way. So if you don't know what you have, you cannot protect it. So it's It's simple. That's where you start. You have to know what you have. The asset management component, if you don't have that down, it'll be very challenging for you to secure your environment, and it'll be even more challenging for you to try to respond in the event of an incident and get back up and running, or even operate through it, if that's the case. So really don't overlook this piece. And it sounds like it's, asset management. How can that be part of security? Well, it's real simple. If you don't know what you have, you can't protect it, and you don't know how to protect it because you don't even know what it is. Or what it does. So that part is absolutely key in the beginning of your program. If you haven't done that or don't do it, you're missing a big chunk of success for your program. The next one is we've got a lot of fragile systems. There are a lot of our legacy systems. They're old. They've been around forever. Probably most of the programs or scripts or code on those machines were written by 3 engineers in a basement, and likely 2, if not 3 of those engineers are dead by now. There's systems running that are still running things like Windows NT, Windows XP. They're very old, and we all know don't look at them, don't touch them. They run that special thing that we do. We're never going to patch it. Just hopefully it'll keep running, and we can not have to replace it anytime soon, because it's a real pain to replace it. It's difficult to change it out. Get that on your radar. Get the change out for those systems on your radar. Start that as early as you possibly can. You've got to get rid of the fragile systems. Those systems are often some of the most critical pieces, and they are that way. That's why you haven't changed them. That's why you don't want to touch them. So you've got to get that out of your environment as best you can. I know you can't do it for all of them, but minimize it where you can. You want to have the least number of unique snowflake fragile systems in your environment. You don't necessarily want a purely homogeneous environment, but you want stuff that you can work with, that you can apply modern controls and use modern protocols, because there's a lot more affordability in some of the tool sets that we've got now. For example, some of the older systems, there is no way for you to even monitor it to know if something went wrong other than it's down and the process is broken. So these fragile systems can be quite an Achilles heel in your overall environment. They increase risk and cost, period. I mean, both of those things translate into money. The next one is architect an environment that you can defend. You need to actually, in some cases, even redesign your network. If you're not going to be building anything new, consider how you're going to migrate the older network onto something newer that is an environment you can defend. If it's one big flat environment where every system can see every other system, that's likely going to cause problems. I mean, imagine what ransomware would do in an environment like that, where it has nothing to slow it down, right? Those things can be hugely detrimental. They can take down an entire environment if it's not architected well. So designing something, for example, I used a castle here in the picture for kind of a visual, but it's the mental picture of, you've got a long field out in front of the castle, typically, so that you can see what's coming at you. In some cases, it's backed up against a cliff or a mountain, or it's on the top of a mountain, so you can see what's coming. It's surrounded, in this case, by a moat, right? It's got water around it that makes it hard to get through with an army. There's a drawbridge, there's a gate, there's all these things designed step by step to make it very hard for someone to get in, and especially get in undetected or undefended. So when you're designing your networks, think about it this way. And there's a lot of talk about things like zero trust and that kind of thing. Our environments historically in the industrial side were never built that way. They were built open because if we needed to get to something or fix something, we usually had to do it quickly. And that mindset needs to slowly shift, hopefully not so slowly shift, toward building environments that we can defend. So you want smaller networks, you want things like a DMZ, and push everything that's not critical outside of a firewall. And look at how you're going to have trust relationships between environments of, critical stuff that you absolutely must trust versus a bunch of other things that you really don't trust, like printers, right? Corporate workstations, pretty much anything other than exactly what you need to run your process and run your operation. But if you don't design it in a way that you can defend it, good luck defending it. It's going to be much, much, much harder. The next piece is I call exposure. There's a lot of industrial control systems on the internet. Just take a look at Shodan and any of the other Shodan-like tools. There's everything from water processing plants and wind farms and chemical. A lot of it. There's some honey-nets out there, honeypots out there as well. But the main thing is, do not put your stuff on the internet. I know that you may need to do it temporarily for something because an engineer says we have to fix something. Really, in any case, unless it is an absolute emergency and what you're trying to do is going to be be higher risk probably than connecting it to the internet, then I wouldn't do it. You really should never connect these systems to the internet under any circumstance. Even then, you do need some kind of remote administration in a lot of cases, whether it's vendor support or you've got a remote facility that you need to gain access to, and it's going to be 3-4 hours of driving a car and a windshield time to get there. That can be problematic as well. So understand things like remote administration, vendor support. Get it? You need those. At a minimum, use things like multi-factor authentication, right? Don't just open it up, and don't make it a steady open pipe with anybody, because you don't know what's going on their side, and you probably shouldn't trust them 120%. So be mindful of the fact that any connection into your environment is an opening. Yes, I understand we have relationships with our vendors that are very strong on the industrial side, but there are ways to use things like multi-factor authentication or just higher degrees of security for means to get into these environments, and never, ever, ever, ever connect them to the internet. This is 2020. It's been quite a year, obviously, but in 2020, we have awesome, great, amazing new tools, and almost every system you bought in the last 5, probably even 10 years will allow you to have unique individual accounts. This may sound strange to somebody in the IT side, but we have a lot of systems where there's basically one administrative account and everyone uses it. And it's usually something like, admin for username and password, or ops. And they even write that down and put it on a sticky note, next to the monitor, which if you can't remember admin, I'm surprised. But that's our environment in a lot of cases. So where you can, and when you buy new systems, use things like, a directory structure and groups. A lot of our, management platforms, a lot of energy management systems and I know plant systems will now allow for, plant operators to have unique logins. And there are some really interesting new creative ways, whether it's through facial recognition or biometrics or even card swipe as a method to get into the system as well. So in the event that you, for example, need to change a shift, you can do so quickly. If you need to access a system, then you can do so quickly. There are methods for this now that actually satisfy our need to, see alarms, get access to the system, and take some sort of action that may be necessary. So we've come a long way to say, and it doesn't have to be where we have to use everything where it's all of the entire plant is in one group with one access to one account. That we can move forward now. It's okay. We do have a lot of vulnerable systems. These, especially in the legacy space, there are some that if you ping them, if you send them a single ICMP packet, they die, they fail. They don't die for good. And in some cases, you just got to go power cycle the device. But yes, it does mean walking over there and pushing the button. And if that button is in some remote facility in the desert or buried in the snow, that's going to be a challenge. So this environment that we've inherited a lot of it. There are some 30, 40, 50, 60-year-old things out there. There's even some 30, 40-year-old digital stuff, quasi-digital stuff. So be careful with it. You don't just run a scanner. Everyone should know this by now. But these vulnerable environments, it's difficult to say you should patch them all because you can't necessarily patch them all. And some of them just need to be protected in different ways. So find out which ones you can work with, which ones you can patch, and obviously treat the ones that you can't differently. Maybe they need to be in a different zone, a different, God forbid, VLAN, if that's all the protections you've got inside of a network. But look at ways to protect those ones that are most vulnerable that you either don't have patches for or can't patch for some reason, or you have to wait for another 2, 3, 4 years for an outage, for example, to be able to update these systems. And even when you do patch them, you patch them in bulk, they end up breaking anyway. Get that. We've got some that are what we call forever days. I think that's a Reed Whiteman phrase, but they're vulnerabilities and they're not going to be patched. The vendor will not be patching them. And this is whether it's insecure by design or the vendor is out of business or they just said, we don't think that's a problem, which happens. Then that's something you've also got to think about in terms of how you protect those systems differently than the ones you can patch and that are less vulnerable. And tradition is something you need to get rid of. I'm sorry. Things are changing so much faster. You can't just say that's the way we've always done things. That is the most dangerous position you could possibly have. You need to take a look at what's vulnerable and protect it and treat it differently. One of the biggest ones, and everyone knows this, but we always seem to forget about it and we don't want to do it, is controlling change. you need to control change, period. Any single change to any one of these systems should go through some degree of review and approval. It doesn't have to be, onerous. It doesn't have to be very challenging or a gauntlet just to get a change done, but someone needs to be responsible for the change, and you need to have a plan for if something goes bad when the change happens. What do you do? Do you back it out? Can you back it out? Do you need people on hand to physically go shut down a process to make it safe? But those are things that you should be thinking about for changes. Control the changes, control the changes. It's like when something goes bad, it's always because a human did something. Rarely, yes, some hardware fails, but it's far less common than a human making a change and just not owning up to it or not being accountable for it. So it is the best defense against both accidents and malice. Humans sometimes make changes with good intention or are good natured, but in a lot of cases there are just accidental changes as well. But this kind of change control and even detection of when changes happen, that's key to it'll stop both bad guys and just accidents. There's this. I have the Hanlon's razor is a big one. Is don't assign to malice that which can be assigned to stupidity or accident. It's most of the time it's just humans being humans and trying to get something done quickly. And then, of course, as I mentioned, monitor. You should be monitoring as much as you possibly can. We've got some great tools that will look at industrial protocols now and industrial processes. A lot of the tool sets we have now, we didn't have even 5 years ago. Our capabilities to see into our environment is absolutely through the roof. I mean, we have a lot of capabilities now we never would have even foreseen even 5 years ago. So look at what is out there. There are plenty of tools from the network monitoring level, from the actual system and process level. Some of these devices take a little bit of extra processing and can't do it, so I get that. At a minimum, take a look at what they're doing on the wire, right? If you can't actually check the device itself, in some cases you can log in and check configurations and pull configurations down at a fairly light touch that won't affect the device. But at a minimum, you want to be looking at what you can see on the network. There's these devices, especially in the industrial side, they can be very chatty. There's a lot of traffic. That's okay. They're also very predictable. They do the same thing on a fairly repeatable basis, and you'll need to know what looks abnormal. So get an understanding of what normal looks like, and then what is abnormal. Would you know abnormal if you saw it, and are you even looking so that you can know if you saw it? I would say 90% or higher of the incidents and events that I've been to, if the security systems didn't catch it, which most of them didn't, then it was a human that actually picked up on it and said, something looks strange. That's because they knew their environment. And giving operations this visibility is just as important as giving the security teams this visibility. I've seen a lot of tools like, your network monitoring tools, your Dragos and Clarity and Security Matters, all of those tools. They were originally there to look for industrial security events, but reality is they're actually just as useful, if not more useful, on the operations side for helping operations actually see what's going on. Because I've seen more light bulbs go off and say, I never knew those two systems were doing that, using that tool from an ops perspective more than from a security perspective. So that gives you a much bigger bang for your dollar, and it's where it's not just used for security, but it's used for operations as well. But this monitor component is absolutely critical. Once you get to this stage and you've done all these other steps we talked about, look at what you can as much as you possibly can. And then, of course, you can use these tools, but then I want to make sure I make it clear, don't go out and just buy every security tool out there. You don't need a bunch of blinky lights acting as space heaters somewhere in your facility doing nothing, frankly. Get a couple of tools, start with those and master them. Use them well, and once you've mastered them, you can look at other tools. If you buy a bunch of tools and you don't put a skilled person behind it, you've wasted your money. If you buy a tool and you don't maximize its potential, or you've got other tools that overlap or duplicate, you're wasting your money. We don't have a lot of money in our security side, so don't waste it. Buy something, master it, use it for everything, and then add on as you need. But yeah, it's kind of like you don't need the remote that's got 5,000 buttons on it if you're not going to use them all. You need just on, off, volume, that kind of thing. So I guess one of the key pieces is lock the doors and windows before you're buying an alarm. If you're not doing all of the fundamentals, you don't need a bunch of these other, fancy tools that will tell you something bad's happening, because you wouldn't be able to do anything about it even if it detected it. So kind of get good at everything else first before you do this. And then moving into, in the event that something occurs, you've found out through your practices, you've designed it all well, and something actually happens. So you've done all this great defense, and then you actually have to go into response mode. If you don't practice this, you are going to have a really hard time trying to respond. This is going to be really, really challenging. And the key thing is you want to try to continue to operate through this. You don't want to have to shut down everything, because obviously if there, in some cases, even shutting down too soon can cause damage to the equipment or even can kill people. So this approach, you need to practice like it's game day and practice often. Get this muscle memory down to where you know what to do in the event that you've got an issue, whether it's pick ransomware, pick a DOS attack, pick system failure, pick whatever you want, wiping malware. Try it and go through it and practice like it's game day. Don't just tabletop this stuff, buy some donuts and set everybody in a room and walk through what you think might happen. Spend the money on a test system. Try it out. Get your hands on it. Get your hands dirty. Do it. Do the actual walkthrough. I'm not saying like damage your systems by any means, but actually have people respond in a way that is as though they would respond. For example, if someone needs to drive somewhere, have them drive. See how long that time takes. If you need to get a system up from scratch and rebuild it, how long would that take? Do it and go through those paces and understand it. When you see firemen practice, they practice with real fire. And there's a reason for that. And they practice really responding from asleep. They have to wake up, get dressed, go in and get in the truck and then drive to a test facility and then put the fire out. So think about it the same way. You need to practice like it's game day, because anything else, you're really setting yourself up for some unrealistic expectations for your capabilities. I hear a lot about regulation. I'm a recovering regulator myself for the US. Regulation won't save everything. You can't just kind of, regulate your way out of this problem. My phrase here is you can prescribe action, but you can't prescribe attitude. You can tell someone what to do, but you can't make them want to do it. Regulation is often just that. It tells you what to do. And a lot of businesses and a lot of organizations, they don't want to do that. Either they lose money or it gets in the way of their operation. It takes more time. It's never something that people will willingly go into. So regulation is a challenge. Hackers are always faster than laws. You will always be able to, technology will innovate faster than you can get a regulation put in place. So between hackers and technology innovation and many other things, regulation is fighting a very strong opposing force. Regulation is there and it should kind of set the minimum bar. You got to be this tall to ride the ride. But other than that, regulation isn't the end solution. I think it's part of the solution and it's a good place to start. But as you can see, the picture here on the bike, my example is I'm going to make a regulation is that if you ride your bike to work, you must lock your bike to a provided bike rack. This bike is compliant. It's locked to a bike rack. And of course, all that's left of it is a frame. It's totally unusable. So that's to demonstrate the difference between compliance to a regulation and actual security. They're two very different things. And set your expectations accordingly when you think about regulation as a solution. Frameworks. Do you just pick a framework and go with it? Yes. The answer is yes. Pick one. And there's a lot of them out there. My suggestion would be try to find one that fits you as closely as possible and follow it. Don't try to create some kind of Frankenstein project from a bunch of different ones. Pick one and go with it because you can measure against it. That is the reason. It's all about measurement, and you've got something to compare against. So when you're asked, are you succeeding? Are we better than we were yesterday? How is our maturity? All of these difficult management level questions that get you the resources you need to secure your organization. If you're not using a framework to compare against and measure, it's very difficult for you to demonstrate that. So to get better at what you're doing and get more resources for what you're doing, find a framework that works for you. There's a bunch of them out there. There's a bunch of good NIST stuff and IEC stuff. There's really good frameworks out there. Pick one and just stick to it for a while and then move over time as you need. But you got to start measuring for success or you won't get there. Last but not least, people. Train your people. After all of the tools fail and everything starts to burn down, it's going to come down to human beings doing what they do. So if you don't have trained, skilled people, you are going to have a very hard time doing your job. So spend the time and the money on the people. Yes, there's the danger of if you train them and they leave, but the other problem is what if you don't train them and they stay? You've got basically untrained, unskilled people with your, very important things. So take good care of your people, train them well. and give them the tools and skills that they need, because they're going to be the ones that actually defend against all of this, because eventually it will get past the technology, right? Some 0 day will happen, or something will get past all of your detective filters. Something will eventually get in, and it's the people that will take care of you at that point. So make sure they're prepared. At the end of all of this, it is about resilience. Everything you're doing there's a lot of focus on prevention. Definitely focus on prevent as much as you can. Detect what may get through your prevention, and then practice your response as much as you possibly can. Know what you have so you can defend well with skilled defenders, because that's how you're going to still be able to operate through an attack. So, whether you need to go back to manual, believe it or not, a lot of organizations that in the industrial side that have suffered from some ransomware outbreaks, if they're skilled enough, they can actually go back to manual operations. Now, can they continue to produce like normal? No, but they can still continue to produce. Business is not dead in the water. Focusing on how do you continue to operate through an attack, not just stop it and respond, but how at the same time, how are you going to keep everything moving? Or not everything, but at least as much as you possibly can. Other parts of this that are a little more subtle or more nuanced, look at, in the event that you're trying to operate through this, how do you try to get some forensic evidence so that you can figure out what happened? The challenge at this point is, once you, contain what's happening, and you start going into not just recovery mode, but not just response mode, but recovery mode, that recovery component is going to be key, where you need to understand what's happening. You may not have an option but to basically start from scratch. If you don't have, a firm understanding of the integrity of your operating environment, you're always going to be concerned, is there still something in there that we need to worry about, right? Is there still some malware running around? Do they have command and control that we don't know about? So the recovery and response and recovery component should have a little bit of that forensic piece, so that you at least get a higher degree of confidence in your operating environment, so that you can continue moving forward. There are some organizations that have literally had to just treat every system as a brick and start over from scratch, and that's insanely difficult to do. But in the event that happens, you should also be prepared for it. Know what you would do in that event, whether it's through contracts or build docs or whatever. That's the ultimate key at the end of the day, is how do you continue as best you can operate through it, and are you prepared for that? So to walk through the review, this is your bullet list. These are the key pieces that you need to do. It's your kind of like your 10-point list. Get your asset inventory down. I know it sounds simple, but if you don't know what you have, you can't protect it. Try to find out where those fragile systems are. Move as many of them as you can into separate spaces, or frankly, just move off of them to something new. Build an environment you can defend. You have to have something that you can actually protect, or you're going to be scrambling everywhere in a very wide environment, just basically getting nothing done. Remote access or external access, if you can get rid of it, great. If you have to have it, secure it. Never, ever connect it to the internet. Use authentication, some authentication. It doesn't have to be insanely long passwords, but use, something that is unique to each user or unique to each environment. Look at ways where you can just take it beyond one account for everybody. Otherwise, you're never going to really get control over your environment from either accidents or malicious actors. Patch where you can, and where you can't, use other methods. There's lots of other ways to try to secure a system where you can't patch, but if you can't patch, you should be doing something else, not just nothing. Change control, you talk about it, everyone knows about it, everyone knows it's the right thing to do, but we are very bad at it in a lot of cases. Get better at it, get good at it. Just make it part of practice. Just bake it into how you do operations. Otherwise, again, accidents or malice can occur without you knowing. And then monitor what you can. Monitor, if you can't monitor, the systems, monitor the network. In a lot of cases, it won't introduce enough latency to cause problems. We have, modern stuff now. We can get past the latency argument, hopefully, at this point. So monitor what you can. And then, of course, over-practice incident response. You should be so good at this that when something happens, there is the least amount of freak out, the least amount of, oh God, what do we do? It's like, okay, we know what to do. You jump up, you go into action, you start looking for what you need to look for. Your tools are all ready to be used, and everyone has those skill sets that they need. Over-practice that so that you're prepared. And then, of course, if you need to go to manual, know what to do, know what recovery looks like, because your downtime is ultimately going to be your demise. It will make or break your company. And some companies have gone out of business because they could not recover. So go through this whole process. Once you get through these and you get moderately mature at all of these things, you're going to be in a far better position in the industrial control system side. So that's my contact information if you'd like to talk to me later, and we can go to questions.